Hey everyone, this is your first episode of the Zephyr Podcast. I'm Benjamin, your co-host.
And I'm Fabio.
So we're just back from the Zephyr Developer Summit in Amsterdam. I think it was last week. Bunch of cool stuff happened in the community, among which based on some discussions between you and I, Fabio, we were like, you know what? We have the tech talks, we have Discord, etc. Are we missing a podcast? And so we're giving it a try.
I think the podcast was the last bit of modern social media that was missing from the project. I hope it doesn't look like we're going to try to do everything and see what sticks, but maybe this is going to stick.
Yeah, I think this will be, some weeks will be maybe more structured than others, but one thing that's for sure is that there's many topics that we can cover, right? And like every week there's a lot of pull requests and lots of activities and interesting bugs being fixed. So sometimes might be more technical than others. Some weeks might be more technical than others. And I guess maybe we should start. Speaking of ZDS, there's a reason, I guess, we're starting this podcast. We typically come back from this kind of events pretty energized, right? Seeing lots of new faces, talking about all sorts of random topics. What are some of the cool things that you saw maybe in ZDS, like talks or demos, like anything cool you want to share?
There was everything going on, really. The main reason for these events is it's to meet people. I think it was actually quite impressive the amount of people that ended up hanging out at the Zephyr booth. I love to spend a bit of time there, see if I get any question, anything like that. And then the various talks had a very good turnout. I think the rooms were filled most of the time. I was usually arriving a bit late, and I was standing behind quite often. It's just great to put a face on what are normally email and see what's going on in the community and really getting up to date with how well people use the project and what people think.
Yeah, and so one thing that I like in those kind of conferences is, like you said, the talks, maybe sometimes you arrive late, sometimes you miss them altogether, but that's fine. You can also catch up on the recordings. Maybe by the time we go live, the recordings will already be on YouTube. But what also is really cool is that we have things like, the birds of a feather sessions, right? And there were quite a few at the conference last week. And what I find is that people from the community, people that we only know from emails, like you said, or maybe we don't even know at all, they're not shy, and they really engage when we have questions and when we really ask we as maintainers, I guess, and we ask the community to chime in and to be like, hey, what are the problems we should be solving? We hear lots of really, really great feedback. And just thinking the documentation buff that we held, I was shocked at the amount of input and feedback we got from the users. So that was really good.
Yeah, we also had one with the maintainers, the Meet the Maintainers, which I jokingly called it Roast the Maintainer. And one of the question, one of the person opened the question saying like, oh, this is maybe going to be controversial. And this is actually the kind of question that I like to hear from the audience, because there may be the more interesting one and something that in an online only scenario, maybe they wouldn't bother reporting to you, but when you're face to face, they're more confident asking for it. This was about a specific platform where the person found that a combination of the driver wasn't quite working. So it's something that we can pick up and try to see if we can improve.
Yeah. So was there any talks that particularly caught your attention or that you found particularly interesting?
Yeah, I haven't seen a lot of them actually, because I was spending a lot of time chatting around. But the talk from Andy Ross, who actually is a colleague of mine, I think he was really cool. He's a great presenter, and he was talking about reworking the context switching code for ARM Cortex M, and this was a The whole work was actually some reaction work from some benchmarking that happened some time ago with the Zephyr code, and there is a bit of a history behind that per se, where the benchmark was done, let's say, in non-ideal condition, because Zephyr, as you know, it's highly configurable, and you can enable stuff like stack protection, or in this case, I think user space, and obviously those options can change performance of critical stuff like context switching in a negative way, but you probably want them for safety or debuggability. But anyway, Andy, as the very smart person that he is and very knowledgeable with this stuff, he took a look at the code and ended up re-implementing an alternative version of the context switching code, and that turned out to have much better performance.
Right, because even with all the proper configuration in place, there was still room for improvement, basically. And so
exactly, and I think Andy didn't like the way that the current code was written anyway. But the takeaway for me was something he said, where he mentioned that even on something so critical as the context switching code, that there is still space for innovating. And if you're passionate about some specific micro optimization like that, there is, like you can do it in a project like this, and it's going to be very, very welcome. So this is still in progress.
So that reminds me actually, and I obviously was too shy, I guess, to mention it, but I don't know if you remember, he had a joke towards the end of the talk where he said, "Hey, kernel is such an interesting space, and hopefully AI is still, humans are still doing better than AI there." And I was actually remembering a few weeks back, whatever is that pull request he did, where he did all that work. I remember running some like AI trying to do some reviews. It felt like it was pointing at some bugs and stuff, but I had no idea how to interpret them, or how to even provide the feedback to Andy. But he said that there were still until a few weeks or a few days almost ago, there were still some iterations needed and some bugs that still need fixing. So I really wonder whether those bugs that he found late were the same that I think the AI and Gemini and whatnot were pointing at. But yeah, that's really cool. Is it? Do you remember? I'm sure you know. So that's ARM, or that's ARM just Cortex M for now?
That is actually Cortex M, and not even all Cortex M. I think it doesn't cover M0 for some reason. These are technicalities. But this is the thing about Andy. He's a very good presenter. And even when opening the talk, he was saying that this presentation is going to have some assembly. And I don't really crunch assembly that well, to be honest, if at all. But it's really good. So this is something that I would highly recommend to watch as soon as it is published, the recording. Even the one from the previous year, actually, there was a presentation about locking, and it's something I stuck with me, and it's something that I still refer to every now and then. That was really good. How about you, Benjamin?
And for those of you non-native speaker watching the recording of Andy's talk on YouTube, feel free to just set YouTube on like 0.5x or 0.75x speed, because there's like the density is. But I'm saying that like in a really positive way. Like there's like really lots.
If you don't speak assembly, slow it down.
Yep, there you go. No, for me, same as you. There's. I probably saw only like half the talks I was planning on seeing, but one was really good. I think it was pretty much the last day as part of the Lightning talks. Verena, a pretty young and new contributor to the community, shared basically her journey into Zephyr, and what was sort of like the experience when it comes to making your first contribution, or even like just setting up Zephyr the first time around. You get to blink your first LED. You're like super excited because you feel like you've accomplished something big, and you're now an expert. And then, the learning curve, we know that it's kind of steep. It's not always. You make progress really quick. Hopefully, the getting started is something you get addressed in a few minutes. But then, there's a few hurdles here and there. So she did a really good job covering that, and it was like, I think I posted that somewhere. Like, one of those talks, like once in a while at the conference, gives you the chills. That was one of them because it was rewarding in a sense to see that people see and feel pretty welcomed in the community, and they get mostly excellent experience. So that was really cool.
Yeah, there is a lot of effort that is put by pretty much everyone that is ever involved in the project in try to have a smooth experience for new contributors. I think maybe she got a bit lucky in picking in the subsystem where she was working on, but I think in general we're doing a pretty decent job. The basic documentation at least is in good shape. You can get away with getting to your first pull request without help, I think, if you follow it. And it covers all the follow-ups and all the details. You can, especially GitHub, the way we use it, the way we integrate with GitHub, it's sometimes not super intuitive, but yeah, it's great to hear good feedback anyway.
Yeah, and there's like in the community, we often, we have some people, some developers in the community who have like half of their time is spent maybe on Zephyr topics, and they do also a lot of Linux kernel development. We definitely use more modern tools, and not making any judgment there, but like for the younger generation, I think they feel more comfortable with things like Discord, GitHub, than good old mailing lists and having to be a master of all things Git to send patches and so on. Yeah, no, you just use the GitHub command line or GitHub GUI, and you do your pull requests right from your IDE, and that's I think that helps.
Yeah, that's for sure. And even having all of the CI integrated with GitHub, you can be somewhat confident that if you can make the CI pass, things are not going to be in a completely horrible shape, at least.
Yep. Or we have, I think was it last week, ZDS, or the week before? Now I forgot. But speaking of like trying code and stuff, I think Alberto gave a talk also on the native simulator, right? Did you see that one?
Yeah, that was excellent, actually. I think that the native simulator is one of the maybe under
hidden gems. I call it a hidden gem.
Yeah, one of the hidden gems of Zephyr. It's not very hidden, but it's maybe something that you don't immediately think about when you're developing an application, but it actually has a lot of value for many different things. Now, we use it for our project for doing all of the testing, including unit testing of some of the internal subsystem as well, which is maybe not the intended thing. Zephyr does have a dedicated unit testing capability, but even for development, there's a number of situations where if you can set up parts of your application to run in the native simulator, you're going to have a lot of advantages. Specifically, you can use native GDB to do source code level debugging without having to have an expensive probe or without having to be tied to the hardware. But also, this is something that Alberto taught me. You can use a bunch of static analysis tool. And a thing that actually made a difference for us was being able to use valgrind on our code, which is actually an excellent tool for finding memory-related problems with your code. And it just finds bug for you very easily. And it doesn't take much to actually set up the project for native sim. If you do, pretty much every subsystem has a native sim driver. Network input, the CAN bus can
display, like you can run emulated graphical user interface.
Yeah, so I actually ended up using it myself for one of my pet projects some time ago. I was doing some UI work with LVGL, and there were some images. So every time I had to flash the device, it was taking maybe 15, 20 seconds. So like, if you're just trying to tweak things pixel by pixel, it takes a lot of time. So I ended up writing some mock driver for the actual stuff that the application needed to connect, and I was able to run just the UI on native sim, and I could just very quickly iterate over it, changing a pixel, was build, was run, and it shows up on the screen of my laptop. So yeah, that was very good.
Yeah, so yeah, that's so I didn't see that one. I didn't see that talk, but I know that Alberto, yeah, he's an expert, obviously, on all things native simulator. So I will certainly catch up on the recording. Maybe by the time we go live, the recordings will already be available on YouTube. And that, by the way, I think that first episode of the podcast will initially be hosted on YouTube as well. So just it might already be like the talks might automatically show up already in the suggested videos. That would be cool.
Yeah.
So yeah, that's for ZDS. What else? We had I think some of the hot topics at ZDS were also things you mentioned, the maintainers session. How can we sort of improve testing with regards to making sure that our user base knows whenever a particular hardware platform or a particular driver has been, at least at some point in time, tested on real hardware. So yeah, the project will be investing on this in the future, and there's certainly demand, like that's for sure. Yeah, that's it. We had a TSC meeting. TSC as in Technical Steering Committee. Of course, a lot of the Zephyr work and Zephyr stuff happens on Discord and on GitHub, and people just like send pull requests and send code, etc. But the sort of longer term technical decisions and like the roadmap when it comes to addressing, like I said, testing issues, etc., we typically discuss those in the context of the technical steering committee with a bunch of individuals representing the community, representing the member companies, etc. So yeah, the face-to-face was packed with lots of topics, which I just mentioned, testing and so on. Yeah.
The face-to-face was also streamed live, right? I think it was free to.
Yeah, that's a good point. So being, people who are sitting on the TSC, they get to like vote whenever there is like some actual decisions that need to be taken. But apart from that, all the meetings are open to the public, right? And all the minutes are out there. We will share the links, right? We need that's also something we need to figure out in the logistics of the podcast. But everything we talk about, we will have some notes, and you can see the links. TSC meeting. The TSC meets every Wednesday. It's a Zoom meeting if you want to tune in.
You have a good point, though. All of the key discussion for the project happen in the open, and something that I usually bring up when people ask me about Zephyr is the vendor neutrality of the project. It's all organized such as no single company can take control of some specific aspect. There's a voting process and everything.
Yep.
Another thing about ZDS, we had the project had a table, and the table was full of boards, but not enough to cover all of it. So I think that the admin would be happy if for next year, if you have an interesting application that you did using Zephyr, and you want to show the board, but even better, like show the application, make it work, you can bring it up.
Totally.
I would really love to see a table just covered in board, one on top of another, because we can fit anymore.
It was pretty full. But yeah, we could do better for sure. And but yeah, that's a good point. Just send it our way too. Like if you have cool demos and cool projects out there, come and say hi on Discord or in the comments. Share it. Maybe we'll even cover it and discuss it in future episodes. Or best case scenario, we have live demos at ZDS or other conferences. So something else as a segue into the next few things we wanted to discuss. The TSC and like the community is currently considering moving the cadence, the Zephyr release. Right now, we do a release every 4 months, which has, it's nice, but it also comes with constraints when we need to release right in the middle of the summer and things like that. So we will likely be moving to, not likely, but we are discussing whether we should move to maybe twice a year and release every 6 months. This is being discussed. In the meantime, we are just right in the middle of Zephyr 4.3. we released 4.2 mid July. So there's already a lot that made it into the tree, right? And so we are looking at like November for the next release. That one won't change no matter what. So yeah, a few things already happened. Anything that caught your eye, Fabio?
Last week I've seen a lot of shields being merged into the tree. Do you know something about it?
Yeah, that happened this week or like over the weekend, whatever. I think this might be. I didn't check with the person and with the author, but it feels to me we were mentioning how ZDS or events like ZDS typically you come back from those super energized. I feel like So yeah, there's someone, Jonas, I think, over the weekend he submitted like 12, if not more, new shields and like sent like lots of really good quality pull requests. It feels to me as if it was just like, yeah, he's back from ZDS and he's like, I want to play, to do my part and to contribute. So yeah, no, that's really cool. And shields, for those who don't know or are not necessarily familiar with the terminology, the name comes from, I think, originally the Arduino ecosystem. This idea of having a main dev kit, be it an Arduino or Raspberry Pi, something like that, or an STM discovery kit, whatever, and having the ability to like physically plug extensions, usually in the form of like additional sensors, I don't know, servo, motor, controllers, whatever, sensors, actuators. And in Zephyr, we have a way to nicely model those physical extensions as basically overlays and extensions to the good old device tree, which is pretty central in Zephyr. So usually, contributing a new shield is a few, I don't know, like 100 lines of code, which is mostly documentation. Basically, the code itself is pretty straightforward. But long story short, that was really, really cool. If you have Adafruit, in this case, Adafruit shields in your drawers and in your lab, it might be that as of this week, they are now supported. Like, I don't know, I don't remember what I saw, but like humidity, illuminance, like there were really a few cool new gadgets.
Yeah, and a lot of them, just to be clear, are not just the Arduino shield. There's a various different format that use the shield infrastructure in Zephyr. So I've seen a few, I think, from you, Benjamin, that uses the microelectronica.
Yeah, microbus.
Microbus. I'm not super familiar with it, but they actually look pretty cool. They're mostly sensor, it seems, and the shield infrastructure is also used for other stuff that are not strictly shield. Specifically, I was trying some time ago to have more boards using the pluggable I2C feature, which goes under a million name, unfortunately. Quick, or I can't remember, Stemma, Qt, stuff like that. So this is actually a good way of just experimenting with things without having to necessarily spend too much time tweaking the code, because you can just use the Zephyr Shield infrastructure and your device is going to show up. That was pretty cool.
Yeah. And something else, I don't know if you saw that one. You mentioned Alberto's talk and like the native simulator. Among the things that you can do with native simulator is really easily and with a really short turnaround time prototype graphical user interfaces. But I think we now have a twister harness for like all things display, right? Like that. Did you see that one?
I've heard about it. It was quite impressive. This just goes after the power harness, which is also pretty recent. Looks like people are picking up on this stuff. What is a twister harness for?
Well, actually, maybe like, how don't you tell us first, like what is twister in the first place? Because like we have we have Zephyr, and then there's like around Zephyr, you hear about West, you hear about twister. Like
we're going from scratch here. So twister is a set of scripts that are used to run some build for the sample and test that are in the tree on a number of boards. So it figures out a certain combination of board and test and sample that it needs to run, and runs them, and it's used in a number of scenarios. So the most common way that you're going to encounter Twister is if you open a pull request, there's going to be a set of sharded workers, actually up to 10 of them, I think, on pull request, that are going to take your code and build it and make sure that it compiles successfully with no warnings or anything like that. And then after the pull request is merged, there is another Twister job that is going to do a similar thing on the top of the tree. And there's some caveat around the whole situation due to the fact that the pull request run is going to try and run tests that are specific to the code you're changing, while what we call the push run, which is the top of the tree, is going to run some different tests. But yeah, this is some Zephyr specific piece of infrastructure that handles the whole continuous integration story. And in the GitHub workflow case, it just does build. It only uses the native simulator and QEMU, or QEMU, how you want to call it. But this is actually capable of doing testing on the hardware. And it is used by some companies to make sure that their board keep building and to test the actual driver and see that they're doing something.
Right. And so, yeah, basically we use it a lot, like, I guess, as like dog fooding, and it helps us keep the code base. We run lots of tests, but it's also pretty extensible, right? And people are very much encouraged to use it for their own projects and their own downstream projects. And a test can be many things. Like a test, I guess historically would be like just a bunch of C-based like unit tests sort of stuff. But with this notion of harnesses, effectively you can have anything. Like a test can be anything that passes or fail. So it can be, we have ways to use PyTest, for example, to help people write more like higher level, I guess, testing scripts. Or recently, for the last release, someone added a harness where basically you can model and describe. You have a given application and you want to test how much energy it draws and how much like power, what's the power consumption, and make sure that it remains in a given like allocated sort of envelope. You can write such tests and run them and see that you don't have regressions, etc. And now back to the display stuff, we have, and I really, really want to test it, we have a so-called display harness where essentially the way I understand it is you use, so that's for testing GUIs with the real hardware. So you have your fancy LCD display hooked up to your dev kit or whatever. Then you have a really high resolution camera and I guess good lighting and so on pointed right at the screen. And the camera is just so high res that it can actually like check pixel by pixel that you're displaying the thing that you think you are displaying. And so you can test that your GUI is pixel perfect, and again, like check for regressions and do everything automatically, which is like, it's mind blowing. I really, really want to test it. Again, we will be sharing the links, some pointers if you want to check it out. Maybe you guys will be beating me to it. But yeah, if you give it a try, I would love to hear about how was your experience, because that's like awesome.
Yeah, it would be interesting to see how they do integration. That's a fairly interesting way of doing it. But on the other side, how else would you check what's on your screen? I suppose you can't really grab a frame buffer because the display may be drawn in date. So yeah, I guess that's what.
You would only test part of like with the camera thingy, you really test the whole thing. Like you test that the pixels are what they are, like that the colors are accurate, and you don't have like a weird like color coding thingy at play. So yeah, and one interesting side effect, I don't know if this is something that can be used for something else, but I was recently sort of updating my the set of Python dependencies in my Zephyr workspace. We are effectively pulling OpenCV now, because that's under the hood. the post processing of the high resolution camera image, I guess, happens with OpenCV, which that's interesting.
Yeah, Twister is very powerful, and I think it's fair to say that the project wouldn't be able to stay together without it. One of the particular thing about Zephyr is the heavy use of macros for everything in the code, and it's somewhat necessary due to the nature of the project that it tries to be obviously resource efficient. So macros are a good way of compiling code out, but then you really need a very comprehensive at least build test infrastructure to make sure that the code even builds, and Twister takes care of doing all of the configuration. So yeah, you're actually it's a good idea to use it for testing anything you care about, and actually we are also starting to plan and use it on some test board in our project. And the interesting thing is that our board don't really use West for flashing them. So I've been working on recently on a new feature that has been merged last week for Twister that allows you to specify an external command for flashing your board, and this can be useful in any application where you need some weird custom bootloader for flashing code, and you don't really want to bother creating a West runner for it, and this can make testing thing fairly simple. This is just one of the many features that Twister support.
Yeah, well, at some point maybe we will just do like an entire episode dedicated to Twister, maybe, or a tech talk, because hopefully I will still be doing the tech talks. But yeah, well, there was actually I think Anas gave a really nice walkthrough of Twister at ZDS, so that's also one talk that you folks might want to watch the recording of.
Yeah, there was a bit of history, and apparently the name is because when he was running the script, his workstation was becoming very loud and trying to take off. Which is certainly something that I experienced as well when I'm running it.
Oh yeah, it's really good at using all your CPUs and so on. Like if you have I don't know, like 24 cores on your machine, make sure that like you can be sure that it will use them all and that it will start eating your CPU like crazy. Because usually when you especially on things like the Zephyr code base, there's hundreds and hundreds of tests, so you parallelize as much as you can. Right. Yeah, I don't know. Like speaking of infrastructure, was there anything else happening recently that's worth maybe sharing, discussing?
Yeah. So another thing that we have a few side projects that we maintain together with Zephyr on different repositories, and one of those that I'm pretty proud of is the Action Zephyr setup one. So this is a reusable GitHub action that you can implement, you can deploy in your application workflow to get a clean environment for building an application from a GitHub project effectively. And the background of this action is that we still do, but we used to get a lot of comment about the size of the project. If you do a default checkout of the whole Zephyr project with all of the module repository, it's pretty comprehensive.
Don't say it. Yeah, don't say the number. It's going to scare people away.
How much is it?
I think it's like anywhere between 15 and 20 gigs, I think.
It's mostly the NXP HAL anyway. Oh, sorry.
Sure. Yeah, no, some of the HALs are big. But I mean, it's a lot. Hopefully, with like modern machines and modern like internet connections, it's not that bad. It only happens once, mostly.
But we were building a bit of a bad reputation to ourselves because of that, right? But actually, it doesn't have to be that way. And it's just that this is the default configuration that allows you to easily get started and do development on any potential platform, running all of the build tests for all of the various architectures that are supported, built for all the 750 board that we support, something like that.
824.
Yeah, that's mind-blowing. So the idea that I had after getting a lot of this question at EOSS a few years ago was to try and put together a short GitHub test thing for seeing how fast you can do the whole thing, check out the project, the SDK, and build a simple application and see how long does it take. And it turns out that the answer was about 1 minute using the free GitHub runner. And then I ended up putting everything into a reusable GitHub action that you
it's 1 minute when you have caching in place as well, right? Like
caching and
caching
only
the repo itself and stuff, like caching the SDK, I think maybe.
Right, and the SDK, and you have only 1 or 2 SDK, but this is kind of realistic, right? Because if you're doing a project, maybe you probably need only 1 tool chain, maybe only the ARM one or the RISC-V one, and then the whole testing.
Possibly only 1 HAL as well, because you only ever care about ST.
Exactly. So we have this section that can set up everything for you, and it has its own testing as well, and it has a bit of documentation. So if you're setting up a CI on GitHub on a project, check it out. It's called Action Zephyr Setup. So something that has been added recently, and this is also something that started from a conversation at ZDS, is that we didn't have support for caching the Ccache data. So Ccache is one of the things that Zephyr uses by default. It's a very generic CC thing that caches the compiler artifact so that you don't have to rebuild everything every time. And the problem with GitHub is that it's fairly tricky to pass this kind of artifacts from a workflow to another. It has a cache action, but there are some caveats where we're using it, specifically the fact that the caches are immutable. So for something like caching a cache, which is going to change every time, it's not exactly easy to use it. So the last week, we figured out a way of setting it up, and this has been merged and hasn't been released yet, as in the latest tag does not point to it yet. But it's something that is going to be available next week. And if you have a complicated setup, it's going to speed up your CI build significantly.
Yeah, and actually that kind of reminds me, I hope we are tracking this, but so Ccache actually saves you lots of time, even like for your local development. And I would really, really recommend, like, if you followed all the instructions to set up Zephyr, you should have a Ccache that's working. But just check, just in case, like you can use the Ccache command line to basically see how many hits and misses you had, and you can quickly do a sanity check there. What I'm was thinking of or remembering is that I'm actually not 100% sure that on the Mac it works out of the box. I kind of vaguely remember that maybe it's broken. So if you're on the Mac, if you feel like Ccache is not working, then we better fix that. But, I remember fixing some local configuration issue a while back, and I was like, "Oh wow, this is so much faster now." You build twice in a row. It's like very much instant.
Well, I can tell you that it doesn't work out of the box on Linux because I changed my laptop recently, and everything was building a lot slower, and I spent a lot of time trying to see what was wrong with my laptop. And then, as it turns out, the problem was that Ccache was not working anymore.
Right. So it looks like we need to actually double check that it works out of the box, because I vaguely remember some PyColibc naming scheme messing up with Ccache or whatever. So that's
I remember exactly what it was, actually, because I did it recently, and because we had to add it in the action. So this is going to be a service notice with great podcast content. So if your build is slow, if your repeated builds are slow, and your Ccache
it shouldn't be. It should be like really blazing fast.
And Ccache-s show a lot of uncacheable calls. Have a look on the issue for Ccache _ignore options, and you want to set this to -spec = star and -specs = star.
I'm sure that sounds very familiar. So I think we need to. There's something that needs fixing. I don't. Whether that would be in the I don't remember where that needs to be fixed, but it needs to be fixed. One thing actually, once in a while, there's. I mean, I have zero experience with it, but once in a while people are like, hey, I don't do GitHub, I do GitLab. So I would love to see the equivalent of the Zephyr, the Action Zephyr setup for GitLab, or God forbid for things like Azure DevOps, which I think is also something I saw someone asking about in a GitHub discussion like last week or something. It would be great to have like those sort of those reference implementations of like, here's the reference implementation of building Hello World Zephyr in CI sort of stuff.
Right.
Yeah.
Do you want to talk about the OCPP pull request?
Yeah.
It's
do you know what OCPP stands for?
I thought they did, but it turns out they didn't. I thought it was Open Compute Project something, but it is not.
I think,
what is it?
I'm not sure about the two P's, but at least one of them is protocol. It's the Open Charging Protocol something. I'm not sure about
charging point.
Charging as in it's for all things electric vehicles. So it's kind of like the standard, which it has open in the name, but I think last time I checked, I'm not quite sure. It's like it's one of those standards that might not be like fully open, but open-ish. And it's kind of like, the standard for how a charging station talks to an electric vehicle and the other way around. How do they sort of like negotiate, authenticate in the case where it's like a paying station with like RFID cards and whatnot, how they negotiate the how many current the car wants to draw, how much current, blah, blah, blah. You get the idea. Long story short, we merged, I think a few weeks back, one of for this release, it might be the oldest PR that's been merged to date. Someone had been working on OCPP support in Zephyr for many years, I think.
For 1.5 years.
Yeah. And so that's one of the things that I've only looked like from a distance, but I know for a fact that I want to build some cool demos with it because it's quite interesting. Like, there's some open source projects out there for building open source and open hardware charging stations, and I'm actually curious to see whether we can have some, I don't know, like even like RC cars, like having some kind of demo where you have an RC car with an ESP32 or whatever running this new Zephyr OCPP stack, and you plug it into a model charging station, and they do the whole thing, and you have the web backend and so on. There's also some open source projects for that. So if any of you have experience with that or have even like started to play with OCPP, again, I'd love to hear about that. Join us on Discord, basically, right? Like, if we haven't mentioned it already, I guess Discord is where we want to have all the discussions with you all. There will likely be, like, if this podcast becomes a thing, we will have a dedicated channel. Otherwise, just spam the random channel. That's fine. But yeah, that was OCPP is quite a big deal, I think, from what I
hope they bring a board to ZDS next year. That's going to be some, we're going to need some space. It's going to go next to the Ampere motherboard, and it's probably going to be even heavier.
Or maybe, Ampere had a really huge motherboard with like, I don't know, like a 200 core CPU. I think some of them, some of the cores are actually running Zephyr. You were talking about how the table was could have been slightly more crowded, but this was actually taking a good chunk of the table. That motherboard.
Yeah, I think we should have a bunch of board over the Ampere board just to make up for the difference in space.
Yep. So all that to say, this was your first episode of the Zephyr podcast. Join us on Discord. Join us. Subscribe so that you don't miss the next episode, which maybe will be next week. Hopefully will be next week. And thanks, Fabio. This was a lot of fun.
Yeah, that was cool. See you next time.